OpenAPI is the world's most widely used API description standard, and it provides a formal specification for describing HTTP APIs. This allows people to understand how an API works and how a sequence of APIs work together. Specification is machine readable, so we can generate client code, create tests, and much more. OpenAPI specification is widely used, so enjoys support of wide range of vendors and tools. Springdoc-openapi is a library that allows automatic generation of OpenAPI documentation for your Spring projects. In this video we'll explore how to use Springdoc-openapi library and what features it provides. We'll create a Spring Boot application that has Swagger UI interface out of the box with a list of our RESTful endpoints and has the ability to generate OpenAPI JSON spec. Before we continue, we'll answer the questions of what problems is OpenAPI spec trying to solve and why was it created in the first place. Let's go through a brief history of how we got here. Around 2000s, XML was prevalent as data exchange format. XML had XML schema definitions, or XSDs, which are also XML files that describe and validate the structure and content of an XML document. You could broadly think of XSDs as class definitions and XMLs as object instances that satisfy restrictions imposed by schema definitions. Because of XML's verbosity and with popularity of web and JavaScript, XML slowly began to fall out of favor for another lightweight data exchange format, JSON, JavaScript Object Notation. JSON is easy for humans to read and write and was especially started to get used as data exchange format for RESTful services. But it didn't have a standardized way to describe what your service has to offer, or, looking from another side, how could you consume a service? JSON didn't have XSD equivalent for XML. In 2010, Swagger came to the scene and proposed a solution, a specification for describing RESTful APIs. The specification creates a RESTful interface for easily developing and consuming APIs by effectively mapping all the resources and operations associated with it. Swagger spec became adopted by the industry and became industry standard, now known as OpenAPI specification. Swagger, and now OpenAPI spec, had a couple of guidelines it was created by. Spec should be written in JSON or YAML format. It would be used to describe RESTful APIs. The goal is to keep the spec machine readable, but also make it easy for humans to understand as well. Although Swagger spec has become OpenAPI spec, Swagger still exists as a website at swagger.io and provides various services related to the specification. On the left we have an example of an OpenAPI spec, and on the right we have a web user interface that Swagger generates automatically based on it that humans can easily read. The best part about the specification is it's language agnostic and it's machine readable, so you can automatically generate servers for various languages that need to implement the spec or clients that should consume it. This is the brief history of what we've been talking about. Swagger came on the scene in 2010, OpenAPI had version 2.0 in 2014, 3.0 in 2017, and 3.1, which is the current version as of this recording, in 2021. In Java and Springland, in 2019, Springdots created a sub-project that should support OpenAPI spec, Springdoc-openapi. Springdoc-openapi is a set of Java libraries that help to automate generation of API documentations for Spring Boot projects. It works by examining your application to infer API semantics. The library consists of a couple of modules that you add depending on whether you're using WebMVC or WebFlux. If you only need the API spec, you include API starter modules, and if you want the Swagger UI, you'd include UI module. If you want both, you just include one single UI starter. To showcase Springdoc-openapi library, we'll create a new Spring Boot project that includes web, actuator, validation, and Spring Data JPA dependencies. At the time of this recording, Springdoc-openapi starter modules cannot be picked as dependencies from start.spring.io site, so we'll add them later manually. I'll generate the project and open it in IDE. We've generated a Maven project, so the first thing we'll do is open our POM XML and add a dependency for Spring.openapi starter. If we wanted to use only OpenAPI spec, we would include API starter. But we want to use Swagger UI as well, so we'll include UI starter. And that's enough to include both OpenAPI spec and UI. In our application properties file, I've defined a couple of properties. One is for the version of Springdots, which we've defined in our POM XML to be 2.7.0, and the other one is for the OpenAPI spec. We'll use the latest one, 3.1 spec. We've included actuator dependency in our project. Actuator exposes various information about our project and our application at /actuator endpoint, and we want to show everything actuator has to offer, and we want to expose actuator RESTful APIs in our Swagger UI and in our OpenDots API spec. We do that by setting the Springdocs show actuator property to true. When we start our application, we can see various actuator endpoints at /actuator, let's say for beans, caches, health, info. OpenAPI spec is available by default at v3 API docs, and Swagger UI at swagger-UI index.html, where we can see various actuator endpoints in Swagger UI interface. We can customize our application API docs and Swagger UI paths by setting up the appropriate properties. And if our application doesn't have anything running on a root, we can set it up so the Swagger UI opens up when you access the root of our application by setting up Springdoc Swagger UI use root path to true. Having done that, we can access the root of our application and it will automatically open Swagger UI. Our app exposes OpenAPI spec at v3 API docs. We can copy the spec, and it's a valid OpenAPI spec that we can paste, let's say, in a Swagger editor, and it will be read, and the same UI as in our application can be generated from elsewhere. Since it's a valid OpenAPI spec, we can generate servers and clients automatically from it. OpenAPI spec is also supported by some other tools like Postman, where you can import a spec and generate collections automatically from it. Another thing you might want to do is to generate OpenAPI spec JSON as part of your build process, and for that a special OpenAPI Maven plugin is available, which I've included in our project. And during the verify phase, this plugin will generate OpenAPI specs in a root of our target directory. And once the verify phase is done, OpenAPI JSON spec is available at the root of our target directory. So far, we've only displayed Spring's built-in actuator endpoints in our app OpenAPI spec. Next, we'd like to add our own custom APIs to our app OpenAPI spec as well. To differentiate our own APIs from the actuator endpoints, we'll create API groups, and we can do that by configuring our property files or programmatically. I'll choose the latter. So we'll create a configuration file for our OpenAPI. It will be a configuration, and the first thing we'll do is create a bean for our actuator endpoint, and it's of type grouped OpenAPI. We'll call it actuator API. As a stub, we'll return grouped OpenAPI builder build. We'll call our group actuator, and we need to tell Spring either paths to match or packages to scan. We'll use paths to match, and in order to get actuator base URL, we'll auto-wire web endpoints properties and get the base path. And we want all actuator endpoints, so we'll include all pattern. That's just a constant from Spring /**. We can further customize our API. First we'll add no arg and data Lombok annotations, and then we'll auto-wire Spring.s version from our properties file, and we'll add a customizer. And we'll add additional info. So it'll be a new info. We can add a version. which will be our Spring.s version, and we can add, let's say, description. This will be actuator API. If we start our app and hit our root URL, we'll see there's a new group for the actuator. We have our description and the version we picked up from the properties file. Next, we want to create a group for our own custom APIs. So I've created a new bean of grouped OpenAPI type. Instead of paths to match, I've given it packages to scan of our current project. So that means that every REST controller and its methods that we create in our own project will be added to this email API group. So let's create email API controller. It will be a REST controller and it will respond to, let's say, API v1 email. It will have, for starters, get mapping. We'll just do a test method and we will start our app. If we now hit our root URL, we'll see our actuator and our email group. And we see that our email API controller has been picked up and our method for test has been also picked up automatically. We can try it out. The next step in our customizations would be to add annotations from Spring.openapi library, like add tag, add a description, and that will be reflected in our Swagger UI. We'll indeed need to go through our classes and methods and annotate them to provide better Swagger UI experience, but before we do that, I want to show you an example of those annotations from real-world project. If we look at a real-world example, we'll see that these API annotations get extremely verbose, so much so we'll have difficulty to read our method signature and our Spring annotations. To help with the issue, we have two options. We can use property files to describe our APIs, or alternatively, what we'll create separate API interface and annotate it with OpenAPI's annotations to describe what our API does, and have our REST controller implement the interface and annotate it with Spring Web MVC annotations and not Spring.s annotations. This way we'll separate concerns and won't have to deal with unreadability and verbosity in our implementation class. To showcase Spring.s OpenAPI features, we'll take inspiration from real-world API for sending mails. We need to say to whom we are sending mail, what's the subject and what's the body of the message. If everything goes okay, we get a 200 status back with the ID and the message. And if something goes wrong, we get 400 or 500 status back with a message describing the error. In our application, I've created an interface email API which has three methods: sendMail, check status, and filter mails. SendMail is the method that will simulate sending an email request. It takes an object or a record that has two subject and text fields and returns back email response with the ID and the message field. Other two methods I've created just to showcase some additional Spring.s OpenAPI features. So the idea here is that our email API controller implements email API interface and that we annotate our email API interface with the Spring.s OpenAPI annotations to describe what our API does. I've changed our email API controller to implement email API interface with the dummy implementation. The implementation itself doesn't really matter. What matters is that we keep our controller clean. We only have annotations that are related to Spring Web MVC, request mapping, post mapping, get mapping, etc. We don't have annotations related to Spring.s OpenAPI. With that in place, if we start our app and open our Swagger UI, we'll see the definition for our three methods. Additionally, we'll also see the definition for the schemas our methods require. The important point here is that out of the box we get a definition for our schemas for the records we provided ourselves, but also for the objects that Spring Data JPA needs, like pageable and page objects. We also get the out-of-the-box definition for our request body for the post method that requires request body and for the parameter for the method that requires path variable. Let's see what else can we get with Spring out of the box. We will include a Spring Starter validation dependency, so if we demand that our email request should be valid, and then go to our email API interface and define that to should be a valid email and it should not be blank. And let's say we defined minimum size for our subject. So we'll say the size is minimum of 3 and let's say maximum of 100. And we'll also say that text should not be blank. If we restart our app, we'll see our changes reflected in a schemas part. We see that to and text, since they should not be blank, they have the required flag, and the subject has a minimum of 3 and maximum of 100 characters validation. If we look at our meta definitions, we'll see that only 200 is provided as a possible response. But if we, let's say, post an invalid JSON to our API, we'll get a 400 back, bad request. And if we execute our filter, API will get a 500 back because our method implementation raises an exception. How do we handle the exceptions? And tell Springdoc-openapi library that 400 and 500 HTTP statuses are valid statuses that our API can return. Luckily, it's not complicated. We'll create new controller advice to handle our errors, and we can say that it's for our email API controller class. And first what we'll do is we'll handle the runtime exceptions. So we'll create response entity, the response that responds to error. We'll call it handle errors. And it will get runtime exception as a parameter. So we'll need to say that it's exception handler for runtime exception, and it will respond with status internal server error. So we'll return response entity with status of internal server error, and the body will be new email error with the localized message of our runtime exception. We can provide similar exception handling for our validation exceptions, which are of bind exception class or its subclasses, and in those cases we'll respond with 400 status bad request, and we'll provide a nice error message that displays field name plus the appropriate error message if the field has one. If we start our app and hit our Swagger UI, we'll see that now we do have possible 200, 400 and 500 response codes. And let's try out our email post requests. 2 is not a valid email, and let's say the subject will place just 2 letters. That's less than the minimum required of 3. If we execute our request, we'll get a 400 status back, and we'll get an error message that subject must be between 3 and 100 characters long, and that 2 must be a well-formed email address. Nice. And if we hit our filter endpoint, we'll get a 500 response back, and we'll get our error message to do. What we see from these examples is that by just doing normal Spring development and including Springdoc-openapi library as our dependency, we get basically the full OpenAPI spec and Swagger UI user interface. Additional thing we could do is provide better descriptions for our APIs, parameters, request and response types, and provide better examples that are more in line with real-world usage of our APIs. For instance, this request body to fields should be a valid email address. The way we can accomplish this is by annotating our email API interface with additional annotations from Springdoc-openapi library that describe how our API behaves. So I've done that so you don't have to see me type. At class and interface level, we'll use add tag and describe what our API does. At method level, we use add operation and add API responses to describe what our API responds with and what it does. And in our API responses, we can provide an example object. Especially used for our multi-line strings that we can use in Java 17 to provide JSON example objects. We can provide example objects for our API responses, but also for our request bodies. In our example, we provided a valid email address for the to field. If we restart our app and hit our Swagger endpoint, we'll see the description of our APIs has changed, description of our methods, and we'll also see that we have a valid example value for our request body with a valid email address. So if our users want to try out our API, they can do so without any hassle and get a 200 response back. In our example, we demonstrated that generating OpenAPI spec and Swagger UI for Spring applications is as simple as adding Springdoc-openapi dependency to our project. A library is tightly integrated with the rest of the Spring ecosystem and provides rich functionality out of the box without us needing to do anything except our normal implementation. If we want to provide better description or other configuration for our users, we can do so by customizing properties or annotating our code. To conclude, if your Spring app provides RESTful APIs, there's no reason not to include Springdoc-openapi library to your project, if for nothing else than for the Swagger UI you get out of the box.